Good morning, dear students. In today's class, we'll again continue the same concept, that is sampling theory. So before going to the problems based on sampling theory, we'll study the main concept of the sampling theory. So today we'll see the one more concept, sampling distribution. What is sampling distribution? We'll see here. Let us suppose that we have different samples of size n drawn from a population. For each and every sample of size n, we can compute quantities like mean, standard deviation, etc. Obviously, these will not be same. Suppose we group these characteristics according to their frequencies. The frequency distribution so generated are called sampling distribution. Means for the given sample from the population, we'll choose what here samples. So these samples, what we'll choose, maybe they having a different kind of mean and standard deviation. So these mean and standard deviation will be not same. Then we'll make a group of this according to their frequencies, and what we are making the group according to their frequencies is so called a sampling distribution. Now the sampling distribution of large sample is assumed to be a normal distribution. See, we have the sampling only if it has what here large samples, means that is more than 30, n will be what here more than 30, then that will be considered as normal distribution. And you know that normal distribution already we have studied in the previous module. The standard deviation of a sampling distribution is also called standard error. Means what standard deviation will find for the given sampling distribution is going to consider as what here standard errors. See, these definitions are very important, you need to remember. So they may ask you to write details about this all in the examination. Now next concept is testing of hypothesis, which is very important. So to reach, what is the testing of hypothesis, we'll see here. To reach a decision about population on the basis of sample information, we make a certain assumption about the populations involved. Such assumptions, which may or may not be true, are called statistical hypothesis or hypothesis. Means by seeing the condition before doing anything, we'll have somewhat here assumption that for example, I can say that I may before writing, according to your study, what you will say here, I may pass the paper or I may not pass the paper, means or I may take these many marks, means I may score this much in the examination. What assumption, that assumption may be true, may be false, but we are assuming something. So such kind of assumptions are going to consider as what here a hypothesis, or we can call it is statistical hypothesis. So to reach decisions about population on the basis of sample information, we make certain assumptions about the populations involved. Such assumptions, which may or may not be true, are called statistical hypothesis. By testing a hypothesis is meant a process for deciding whether to accept or reject the hypothesis. This method consists of assuming the hypothesis as correct and then compute the probabilities of getting the observed sample. If probability is less than a certain pre-assigned value, the hypothesis is rejected. Now we'll see what is errors. We have two kinds of error. One is type 1 error. Second one is what here? Type 2 error. If a hypothesis is rejected, why it should have been accepted, we say that a type 1 error. You have to remember what is type 1 error. If a hypothesis is rejected while it should have been accepted, means instead of accepting, if you reject the hypothesis, so that kind of error is going to called as type 1 error. Similarly, if a hypothesis is accepted while it should have been rejected, we say that a type 2 error. Means here we have accepted, so but it could have been what here? Rejected. So such kind of this one hypothesis is going to called as type 2 error. But to reduce these both the hypothesis error, so if you increase the sample size, so automatically as increase the sample size, that errors will be what here going to be decreases, means we can reduce it. So next is null hypothesis. So null hypothesis, the hypothesis formulated for the purpose of its rejection. The hypothesis formulated for the purpose of its rejection under the assumption that if that it is true is called null hypothesis, and the symbol is denoted by H0. The hypothesis formulated for the purpose of its rejection under the assumption that it is true is called null hypothesis, denoted as H0. Means always will take what here? A false value and will start the problem. At that time, that condition what we'll consider as a false is going to consider as what here? Null hypothesis. Any hypothesis which is complementary of null hypothesis is going to called as alternative hypothesis and denoted by capital H1. The hypothesis formulated for the purpose of its rejection under the assumption that it is true is called null hypothesis, denoted by H1. Any hypothesis which is complementary to the null hypothesis is called alternative hypothesis, denoted by H1. So this is one of the important concept to start the examples. So once we got what is hypothesis, what are the errors, then null hypothesis, we'll see the significance, level of significance, and what are the critical values, so under which this level of significance will fit, and for what level of significance we need to calculate the respective problems and all, we'll see here now. Now significance level, which is denoted by Z alpha, the probability level below which we reject the hypothesis, known as level of significance. Means level of significance having a fixed point, means we'll have the one of the values for that value. If the given probability level is coming below or less than, then we can say that the given hypothesis is going to be rejected. So the probability of level below which we reject the hypothesis, known as level of significance. Next, what is the test of significance and confidence level? We'll check here. So what is the confidence intervals and all, we'll check everything. So the process which help us to decide about the acceptance or rejection. Means, so the value which decides to accept the hypothesis or reject the hypothesis is called the test of significance. The probability is conventionally fixed at, so we have two values from where we are going to test the level of significance. If this level, the value, what value we getting from the probability, so if it is less than, we'll accept. If it is greater than, we reject always. Okay, so which are those values, we'll see now here. The probability is conventionally fixed at 0.05 level of significance, or 5% we called, or we have one more value, 0.01 level of significance, or 1% level of significance. So both we are going to test in the examination, or they will give you test for 5% level of significance, or 0.05 5.5 level of significance, or in other part like that. So at that time we need to check that probability and what is happened. So here we have a few results. So table of critical value, nature of the test. So two-tailed test. Two-tailed test means we have both. I can say this is a graph for here. So this is a normal curve. So we have two-tailed means it will come both. So both the left hand side as well as the right hand side. One-tailed means it will be positive side, and means right tail test positive, and left tail test means negative side. So here what happens, what I had drawn here, so these are the values, minus 1.96 and plus 1.96, and what this area is there, this area is going to called as critical region. So this area is nothing but what here called a critical region. So here this is also a critical region on the left hand side. So the critical region is nothing which considered as 2.5% and 2.5% here. So 2.5 will get what here completely 5%. Okay, so like that we are going to calculate for the level of significance. So we call it is if you consider complete this graph, at that time it will be two-tailed. If you consider only right side, it is one right tail test, and if you consider only the left hand side, it will be what here left tail test. So based on this we have the values here. So these values you need to remember. So nature of the test. So two-tail test means complete graph, right tail test right hand side, left tail test means left hand side. So for two-tail test means complete. So at that time level of significance for 1% it is 2.58. You need to remember the value, and for the 5% it is 1.966. If your calculated value, what we'll get from the probability, if it is less than, we'll accept the your hypothesis, or if it is coming greater than, we'll reject it in both the cases. Similarly, right tail test. So here the value of level of significance is 2.33, and for 1%, and for 5% it is 1.645. Similarly, for the left tail test, the same values but in what here negative direction. So minus 2 times 33 for 1%, and minus 1.645 for 5%. So this critical value table and the diagram and this process what we have, that is a significance level. So we can go for the problem, and we need to check whether the given sample is having accepted or rejected based on significance level. So this is a table. So this is a mu graph, mu value. So graph is this is what we have drawn. It is normal curve. So what shaded part is there? I told this is a critical region, and critical region having 2.5%, and here also a critical region, it is also 2.5% on negative side. So both are critical and region. So this both what unshaded part is there, we call this acceptance region. So based on this we'll see whether the given graph given problem having two tail test, or we can say that it is a right tail test or left tail test. If it is two tail test, we'll apply for 1% 2.58, and for 5% it will be 1.96, or else it will be what here 2.33 and 1.45 for the either right or left. If it is right, with positive sign, and if it is left, it is negative sign. So with the help of this, so we'll see what is the again a few more concept with examples.